6.4, comparing linear versus nonlinear functions. So we know linear and nonlinear. Well, linear, what do you think is going to be a straight line, and nonlinear is going to not be a straight line. And we know they're both going to be functions. Functions means each input goes to only one output. So the graph of a linear function shows a constant rate of change. It's going to be a straight line. A nonlinear function does not have a constant rate of change, so its graph is not a straight line. So when we are looking at tables to determine whether they are linear or nonlinear, we're looking to see if there's a constant rate of change. So on this one, my x's are going up by 3 each time, so plus 3, plus 3, plus 3. My y's are going down by 8, minus 8, minus 8, minus 8. Because there's a constant rate for my x's and a constant rate for my y's, I know it is going to be linear. In other words, if I were to find the slope between these 2 points, it's the exact same thing as if I were to find the slope between these 2 points. The slope is constant, meaning it is going to be a straight line. However, when I look at this next one, it's plus 2, plus 2, plus 2, so there's a constant right there. But my y's, I go plus 9, then plus 22, then plus 55. So this one would be non-linear because it does not have a constant rate of change. It's going up faster and faster and faster, so it's going to be a curved line. If you're given graphs, it should be very quick to determine whether it is linear or nonlinear. You just have to decide, is it a straight line or not? So A is not a straight line, so we know it is non-linear. B is a straight line, so we know it is linear. Okay. All right, go ahead and try 1, 2, and 3 and determine whether each of those are linear or nonlinear. All right, so check and see how you did. So on this one, I'm going up by 7, up by 7, up by 7. I'm going down by 5, down by 5, down by 5, so I know it is linear. On the next one, I'm going up by 2, up by 2, up by 2, and then I'm going down by 4, down by 4, down by 4. So this one is also linear. This one, well, this half is linear and this half is linear, but because it changes from going up to going down, it is not linear the whole way, therefore it is non-linear. And in fact, this is what we would call an absolute value graph. You don't need to know that, but you will get to that eventually, and just kind of recognizing that absolute values are not going to be our linear functions. Okay, so our next one, let's just see, this is y is equal to 4.7, y is equal to 4 over x, y is equal to, that's a pi x, and then y is equal to 4x minus 1. So determine whether each of these are linear or nonlinear. Well, if it's just y equals a number, we know that that is going to be a horizontal line, so we know that that is in fact linear. If I have y is equal to pi x, well, that's the same thing as having y is equal to 3.14 approximately x. So that one's going to be linear because we can see what our slope is. When we get to this one, we have 4 divided by x. There's no way you could write this as y equals mx plus b because x is in the denominator. If your x is in the denominator, automatically it's going to be non-linear. This one, we could use our distributive property and it would become y is equal to 4x minus 4, and then you can see it can be written as y equals mx plus b, therefore it is linear. So if you're looking at the equations, if it can be written in the form y equals mx plus b, then we know that it is going to be linear. A quick note about a, you could technically write it as y is equal to 0x plus 4.7. So it can be written in y equals mx plus b format. All right, 4, 5, and 6, let me fill in. This should be y is equal to x plus 5. This one should be y is equal to 4x divided by 3. And the last one is y is equal to 1 minus x squared. So take a look at those 3, 4, 5, and 6, and then pause the video and check and see how you did. Okay, so for the first one, yes, it is linear because it can be written as y equals mx plus b. For the next one, you actually could write this as y is equal to 4 over 3 with x next to it. That's the same thing, and technically there is a plus 0. So it can be written in the form y equals mx plus b, so it is linear. The last one, though, has an x squared on it. If you have an x squared or an x to the 3rd power or x to the 4th power, automatically that means it is going to be non-linear You can't have a variable, an exponent on your variable. All right, so take a second, write your summary. How do you know if it is linear or nonlinear? From a table, from a graph, or from an equation. So those are 3 formats you want to make sure you can identify whether it is linear or nonlinear.